let's have a look at diamond now, which is also made from carbon. And silicon dioxide. Can somebody tell me what they think, whether they know about silicon dioxide? What's its common name? Quartz. And this now is a three-dimensional structure, which is challenging to draw. And I know I'm not going to do a very good job of it. But what we want is this time each carbon is bonded to 4 other carbons. It gets pretty messy pretty quick, so I'm not going to even try. But this is a tetrahedral shape. So if we, you've built your methane before, it's the same shape as that. And so this means that all of our electrons are fixed in bonds. Covalent bonds are really strong, so very high melting and boiling points. Just a melting point. And it's also very hard. So for diamond, on Mohs scale of hardness, it's got a hardness of 10, which is the hardest thing we know. The reason it's so hard is because these are strong bonds and it's in this ongoing crystal, three-dimensional crystal lattice. Okay, so this is an ongoing three-dimensional crystal lattice. And we've got this model here. If you have a look at it, this is one arrangement of diamond, but if you have a look at it, you can see that there are 4 bonds for each of the carbons, and it ends up being a very stable structure. We can synthesize diamonds now, but for a long time it was very difficult. And in nature, it's synthesized in the mantle, where it's very hot, high temperature and pressure. And we use them in industrial applications, like not just jewellery or whatever, but we use them in drills, etc., and saw blades.
Is it heavy?
No, not particularly heavy, no. And again, I guess if it were a metal, we would expect it to feel heavy, but it doesn't have any. Doesn't really behave like a metal at all, is it? Now, I've got silicon dioxide up there as well as another example, but the way I've written it there, shouldn't it be an ionic compound? Why wouldn't it be ionic?
Does it have something to do with the 2 oxygen?
No, not really.
Silicon and oxygen are both non-metals.
Yeah, okay, so non-metals. So it can't be ionic bonding. Silicon. Yeah, but what we've got here is a non-metal bonding with a non-metal. And so this is the ratio that they're present in this ongoing crystal structure. So we call that the empirical formula. And if I change my diagram to try and make it representing silicon dioxide, what I do is if my red circles are silicon and the oxygens are the blue circles, if you look to see, well, how many oxygens are there for each silicon? So if we look at the silicon in the middle here, it's got half, 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 half from each of the bonds it's sharing with the oxygen in between. So 4 halves adds up to 2. That's why it's silicon dioxide. And that's why I'm not going to try and draw any more than that. Okay, because it won't be pretty. But students often get confused and they think that that's an ionic substance because you get used to that sort of formula arrangement, but it's not. It's covalent network structure, and again, it's also very hard and has a high melting point, and we often see it on beaches. Beaches are made of often quartz sand because it is hard and insoluble, and it's made up of an ongoing 3D crystal lattice in a covalent network structure where all of the electrons are shared in bonds. Okay, has anyone got any questions about that? So we've talked about graphite, graphene, buckyballs, diamond. There's also another arrangement, which is an amorphous arrangement for carbon, which is soot. It just means it doesn't have an ongoing structure. And these are all allotropes. Okay, so the allotrope here is just about the way the bonds are arranged. So carbon is special, along with some other elements, but carbon is the only one that we consider that can form all these different structures, and so we call them allotropes. Oh, that's not very good way, does it? And you do need to learn the word allotrope. Just telling us, as I said, that it's possible for carbon to form bonds that form quite different structures that have quite different properties.